Now let's look at an extension to the transshipment problem, the red brand logistics problem that we looked at earlier. In the previous problem, we had just one product that was flowing from the origin to destination. What if we have multiple products? So let's look at a case where there are two products. So we have plant capacities for the two products and then the demand for the two products. Okay. And then in the arcs themselves, capacity for shipping the two products together. So our capacities will be combined, but the flows must be separately accounted for each of the two products. So let's look at the Excel file. So here we have common arc capacity, which is given as 300. Let's color code that, so name that cell. Okay. So now I have the origins and destinations already coded here, and the cost, unit cost is given right here. Let's format this properly. Okay. Then we have two flows, flow for product 1 and flow for product 2, which we have to determine as changing cells. Then when you add the two flows, that will give us the total flow, and that should be less than or equal to the arc capacity, which is the common arc capacity. So let's copy this. Okay, now let's name all of this. So this is one set. Then we have the arc capacity, which we can even use that one. So we don't, well, let's not name this. Now we have the plant capacity for the two products, and then demand for the two products at the destination. So let's align the labels properly. Okay. Now let's set up the net flows for the different nodes. So it will be net outflow for the origin nodes, that are the source nodes 1, 2, and 3. And then net inflow for the customer nodes, that will be the last two nodes, the demand nodes. And the intermediate warehouse nodes can be either way. So I'm going to set it up as net outflow. All right, so it will be sum if, okay, the range is origin first going out, then we need to do this one product at a time. So product 1, okay, minus sum if destination. So what's coming in to this node, and for product 1. Now for product 2, okay, you have to do a similar formula. This time, okay, origin is same, node is same, but flow should be for product 2. So that's going out minus sum if destination that node and flow of product 2. And these two should be less than or equal to the two capacities respectively. So let's do it this way. Align it. Now we can copy these two down here. So that takes care of the origin nodes. So we can copy this over here. Okay. And that should be equal to 0 for the two products. This is for the warehouse. Now we copied these down here, but now we have to reverse the plus and the minus because we are looking at net inflow. So what is coming in must get a plus, and what is going out must get a minus. We have to do the same for the second product as well. What is going out gets a minus, what's coming in gets a plus. Now that should be equal to the destination demand. So we copy these two down here. Okay. So now we need to set up the cost here. So that will be the sum product of the total flow and unit cost. So let me write total flow, okay, comma, unit cost. Now that is our objective function that should be minimized. Okay, and let's now give names. So that is our objective function. Okay. Here there is a problem. The title here is the same for the plant and the warehouse. So it's going to, the names going to clash. So we have to change the names. Let me call it net warehouse outflow. It's going to be kind of long. Okay, so net warehouse outflow for product 1, and we'll call this net warehouse outflow for product 2. When we do it that way, then there will not be a conflict in the name, and we can go here to formatting, and we can do a wrap text, and that will wrap the text in this fashion so the entire name will show up. Alright, now let's give names. We need to do control, click and drag. We won't give a name here because we can just use the number equal to 0 in the constraint. Now let's run solver. We want to minimize the total cost, so that's that. We'll change that to minimize. And changing cells are going to be, we'll do it one column at a time so the names will show up. First flow and then the second one. Now constraints, again let's do the constraints one product at a time so that the names will show up in the solver parameters. So net outflow product 1 is less than or equal to capacity of product 1. Okay, and then net outflow of product 2 is less than or equal to capacity of product 2. And then warehouse, so that should be equal to 0, and the second one should be equal to 0. And then we have the net inflow for customer demand, so that should be equal to the demand. And then same for the second product, should be equal to that demand. Okay. Then we have one more constraint, which is the R capacity. So our total flow should be less than or equal to the R capacity, and we can use that single cell of R capacity right there. Click OK. So we have the constraint set. So we have make unconstrained variable non-negative simplex LP. Okay, make sure everything is good. Now solve, and we have a solution